Hello everybody, this is Gus from Relay Corp. I'm going to be doing a technical introduction to Relaynet for service providers. So if you're offering an internet-based service and you want to make it resilient to internet blackouts whilst also protecting your users' privacy, I think you'll like this video. This is what we're going to be talking about. We're going to start with why I think internet services are typically brittle. And as you'll see, I don't think it's because of the internet per se, but because of the way they are typically built. Then we're going to be talking about how Relaynet makes all services resilient. We'll then cover how Relaynet will also make it possible to have different degrees of centralization. So we're not limited to fully centralized or fully decentralized services. The next point will be the privacy and security guarantees that Relaynet offers. And we're going to end with covering what it will be like to integrate Relaynet in your apps. So first, why internet services are typically brittle? In my opinion, that's because they use RPCs. An RPC is an architecture where you have a client and a server, and the client makes requests, and the server has to reply to each individual request. So you're very likely very familiar with this architecture. This is what pretty much everybody uses when they are integrating services or software over the internet. Now, this is I think the reason for this is that it's just very easy, and it's a very familiar concept because it resembles local function calls in your application. So if you're using a third-party library, this is essentially what you will do when you call a function. You call a function, pass some input, and you get some output. However, I do not think that they are well suited, that RPCs are well suited to the real world, especially over the internet where so many things can go wrong and will go wrong. For example, this architecture requires the client to have a live connection with the server, but obviously that will not be the case if the internet is unavailable, for instance. It also happens to require that the server be able to respond whenever the client makes a request, but the server may be down, for example, and that may not take place. The latency is also so the RPCs assume that there will be a low latency. If there is a very large latency, they simply will not work, and the effects will be particularly noticeable if you are using TLS, as is the case today. So because you will have to be doing that round trip that is part of the TLS handshake before you even get to send the data that you're supposed to be sending. Now, let's see how Relaynet changes that, how Relaynet makes all services resilient. The key difference is that Relaynet services will not be using RPCs. They will be using a different integration architecture, which we call asynchronous messaging. In asynchronous messaging, you don't have clients and servers, and you don't have requests and responses. Instead, you have endpoints. So there is no hierarchy here. They are both equal, and it's like a peer-to-peer model essentially, and any endpoint can send a message to any other endpoint, assuming that they have the right permissions to do so. So there is no requirement whatsoever for the recipient of a message to respond immediately with another message to the sender. Messages can be as many. Any endpoint can send as many messages as they want to, regardless of whether or not there is a reply or not involved in that communication. And the main reason for using asynchronous messaging in Relaynet is that asynchronous messaging acknowledges the real world. It doesn't assume that the two peers will be able to communicate with each other immediately or when the sender is available or wants to do it. Instead, so endpoints are not responsible for the delivery of their messages. Instead, the sender will delegate the delivery of each message to one or more brokers. And what that means is that, for instance, the message is going to reach its final destination as soon as the destination can be reached. So if the destination is unavailable for whatever reason or cannot be reached, the broker is going to retain the message until it's been safely delivered. It also means that brokers can use fallback media when the usual transport is unavailable. So for example, if the internet is cut off or heavily censored, the broker can switch to, say, if it's heavily censored but available, they can use a different service like email, for example, to send the data and receive data. And if the internet is totally cut off, they can use sneakernet, like for example, depending on a Relaynet courier for the transport of the data offline. As we'll see in a moment, Relaynet does not limit you to have fully centralized services or fully decentralized services. It supports both and also a hybrid of the two. So let's consider what would happen with a centralized service. Let's pretend that Twitter supports Relaynet. This is essentially the architecture of all the communication that will be taking place between that Twitter app on my phone and the Twitter server. So what would happen is, typically, if we were using the internet, the Twitter app is going to be directly communicating with the Twitter server. So it will be making HTTP requests to api.twitter.com. That is not the case with Relaynet. Instead, the two are going to communicate via these two Relaynet brokers, which we call gateways. More precisely, this one is a server-side app, which we call public gateway, and this is, in this case, is an Android app, which we will call a private gateway, but it can also be a desktop app if that's the platform that the user is using. So what happens is, say that the user is writing a new tweet. As soon as they hit send, the Twitter app is going to encrypt that message with the key from the public key from this server, and it's going to sign it with its own key. The resulting message, which is going to be signed and encrypted, is what we call a parcel. So a parcel is going to include that JSON serialization of the tweet in this case, but the private gateway is not going to see what's inside. It will not be able to see that it's a JSON serialization of anything, especially not the fact that it's a tweet. So it will just see what's outside and some metadata that we'll cover in a moment. So it will pass the parcel as is to its public gateway. And the public gateway is, because it's an internet server, it will have its own address. And an example of an address could be something like europe.relaycorp.tech. So as soon as the public gateway gets that parcel, it will pass it on to the api.twitter.com server in this example, and the twitter.com server will decrypt it after checking the signature, and it will find that there is a JSON serialized tweet inside. Now, if we consider the opposite direction, this is the recipient, but it will not have a URL because it can't be reached from the internet. Instead, this is going to have what we call a private address. So this is a private node, a private endpoint, because it can't be reached from the internet. This one is a public endpoint because it can be reached from the internet. Its address will be something like api.twitter.com/relaynet. However, this one will have is a private endpoint, and it will have a private address as a result. This private address is opaque, and it's based entirely on the public key of the app in this case. That means that it can't be mapped to any device or any user. So what will happen is the server will know that this user is using the europe.relaycorp.tech public gateway, and that means that when it wants to send a message to this app, it will encrypt it with this app's public key, it will sign it, and it will pass the resulting parcel to europe.relaycorp.tech. And if the internet is available between these two, then the private gateway is going to get that parcel and pass it on to the Twitter app. One thing that you should keep in mind as a service provider is that you're only responsible for your for your apps. So in this case, the Android app and the server-side app. You're not responsible at all for the two gateways. The user is responsible for those. So in this, or more precisely, the user is responsible for installing and keeping the Relaynet app on their phone or laptop, and the public gateway, by default, when the user installs the private gateway, it will be paired to a public gateway operated by Relay Corp, but they can change that if they don't want that. So they can, if they are tech savvy enough, they could run their own public gateway if they want to. But by default, they don't have to worry about this either, because there will always be one that they will be paired to initially. And so that means that you, again, as a service provider, you don't have to worry about the gateways at all. Now let's consider a decentralized service. Let's pretend, for the sake of this example, that WhatsApp supports Relaynet, and because they support Relaynet, they have chosen to take it to the next level and just decommission all the servers they used to operate to offer WhatsApp. What will happen in this case is very similar to what we described earlier. So let's say that Alice and Bob want to communicate with each other, and what will happen is, if Alice wants to send a message to Bob, she will type the message, hit send. The WhatsApp app is going to encrypt it with Bob's public key. It's going to sign it with its own key, and the resulting parcel will be passed on to the to Alice's private gateway, which will in turn post it to Bob's gateway. And this may or may not be the same gateway, public gateway, that Alice is using. For example, Bob's gateway could be europe.relaycorp.tech, but Alice's could be something like usa.relaycorp.tech. So once Bob's public gateway has got that parcel, it will pass it on to Bob's private gateway, which will pass it on to Bob's WhatsApp app. And one thing that I haven't mentioned before is that the signature of the sender is always going to be checked. So it will be checked by the gateways to make sure that it was really this, the sender is truly who appears to be from the metadata of the message, and that they are authorized to reach the recipient, which we'll cover in more detail later. And the converse is very similar to what we just described. So let's say that Bob wants to send a message to Alice, then the WhatsApp app is going to encrypt it with Alice's public key, sign it with its own key, pass the resulting parcel to the private gateway, which will post it to Alice's public gateway at usa.relaycorp.tech, and that will pass it on to Alice's private gateway, and again that will pass it on to Alice's WhatsApp app. And as I mentioned earlier, so these two examples are the two extremes, so a fully centralized service and a fully decentralized service. You can combine the two if it makes sense for your specific product. So what that means is that you could have, internally, you can break up your service into multiple Relaynet services if it makes sense for you. You can still have the same app, and the user does not have to know anything about this. It's just an internal organization approach. So let's consider what that will look like in the two examples that we covered a moment ago. So let's say Twitter wants to also use Relaynet for direct messages. They can use a fully decentralized subservice to support direct messages. Also, on the other hand, if we consider the WhatsApp example, they could optionally implement a centralized user directory to make it easy for users to connect to each other. So as we'll see in a moment, every message that is sent to a private endpoint has to be pre-authorized by the recipient. If the sender is not pre-authorized by the recipient, then the gateways along the way they will drop the message as soon as they discover that, and they will be checking that for each message. So if WhatsApp wants to move away from this fully decentralized approach to add a server just for the initial introduction between two users, they could do that, and that will offer obviously a better UX. And they will, in this example, they will only be responsible for that very specific servers rather. They will not have to be, so that will be the only server that they will have to maintain. Otherwise, they can continue to use the fully decentralized service for the actual delivery of the messages. Let's now look at the privacy and security guarantees that Relaynet offers. And let's begin with looking at the structure of a parcel. So as we mentioned earlier, every service message gets encapsulated into a parcel. And a service message can be, for example, a JSON serialization of a tweet, or it could be, for example, the protocol buffers serialization of a WhatsApp message. It can be text-based or binary, it doesn't matter from Relaynet's perspective. So the structure of a parcel is as follows. The first thing is the recipient's address. This address can be a URL if the recipient is a public endpoint, like, for example, api.twitter.com/relaynet. And that's assuming, of course, that the service is centralized. The other alternative, the other type of address could be an opaque address, which is, again, the private address of the endpoint, which will be derived from from its public key. And that means you, for example, if as a service provider, you get to choose which one you use when you have a centralized service. So when you have a centralized service, you can either use the URL address or the opaque address for the server side. If you are running a fully decentralized service, then you don't have an option. All addresses are opaque. We'll cover the differences in a moment, but it's basically to do with the type of address determines the authorization checks that will be performed. We'll cover that in a moment. The other piece of data that can be seen from the outside is the message ID. This is just a unique random ID that it gets assigned to the parcel in this case to make sure that we are not delivering the same parcel multiple times. Then we have the creation and expiry dates for the parcel, just to make sure that the parcel is not, just to make sure that the parcel is still valid and we are not delivering a parcel that expired. Then we have the service message, but in encrypted form, so from the outside you can't see what's in it. And finally, we have the certificate of the sender. And obviously this certificate will have been used to sign the whole parcel. Let's now consider what goes on in the end-to-end encryption. As we mentioned earlier, all service messages are encrypted. So the parcel, the payload of the parcel is the encrypted service message. So that JSON tweet or that protocol buffers WhatsApp message. Keys are constantly being rotated. So this way we mitigate the impact of any keys being leaked by accident. And one thing that is very important for you to know as a service provider is that you don't have to write any code to do key management. It's all done for you in the endpoint library that you will be integrating in your software. You just have to integrate that piece of the code to do the key management operations, but you will not have to write code to do the key management per se. Now, authorization, and this is one of the things that I'm the most excited about Relaynet personally. Messages bound for public endpoints like api.twitter.com/relaynet are always delivered. The fact that your service is using this URL means that you are willing, in principle, to receive any parcel from any gateway. However, you can change that. So if you use private endpoints, then gateways will be enforcing pre-authorization. That means that the recipient must have pre-authorized the sender to actually send them messages. So when we saw the structure of a parcel, that sender's certificate will have to be issued by the recipient in the case of in the case that the recipient address were a private address. If that's not the case, then the gateway will the first gateway that finds it will drop it. And if for whatever reason the two gateways fail to notice that due to, say, a security compromise or a bug in the code, then as a last resort, the final endpoint will also check that signature to make sure that the sender truly is authorized to reach that endpoint. In the future, pre-authorizations will optionally set at rate limits. So as a user, you could do something like restrict how many messages you can get in any period of time. So you can say, I'm willing to get up to one message per week from this sender. You will be able to do that. Now, what this all means is that as a service provider, you will not have to worry about denial of service attacks, spam, or phishing. And this is a massive deal, as you can imagine. Of course, Relaynet the public gateways will still be connected to the internet, and they will still be susceptible to denial of service attacks. But as a service provider, this is not something that you will have to worry about if, for example, you decide to only use private endpoints. If you use public endpoints, your service will still be free of spam and phishing, but you may be susceptible to DDoS attacks, for example, if you are using a public endpoint. Now let's talk about what it will be like to integrate Relaynet in your apps. There are basically 6 operations that you will be responsible for. So the first 2 is to do with creating endpoints for your app. If you wanted to, you can have just a single endpoint for all the communication in your app, but that may be okay depending on what it is that you are doing. It's like in a centralized, if you only have one recipient that you are going to be talking to, that's okay. But if you can have multiple, I would highly recommend that you create separate endpoints for each recipient. This way, if one of those recipients were compromised or were a malicious user, they will not be able to do any kind of like fingerprinting or identify you as the sender of other communications that they might have been able to intercept. So again, this is just for privacy purposes. So you may want to create separate endpoints for each recipient. Then the next 2 operations are to do with the peers that endpoint that you've got will be talking to. So you will be registering a peer by passing the peer's certificate, and if that peer is a public endpoint, then you will get the option to pass the public address of that endpoint. And similarly, when you no longer need to communicate with that endpoint, then you can unregister that endpoint by passing the private address. Now, the next 2 are the ones that you really care about, obviously, as a service provider, the functions to send and receive messages. So when you want to send a message, you essentially pass the message that you want to send unencrypted, followed by the private address of the recipient. Now, behind the scenes, this function is going to be doing all the encryption. It's going to be taking care of picking the right key and everything else, so you don't have to worry about that from when you call this function. This is all done for you. Then finally, we've got the function to receive messages for one or more endpoints. And there will be 2 flavors of this function. One flavor is when you have your app running in the foreground and you don't know how long the user will be using it, so it will always be running in the foreground, so you can get messages as they come. The other flavor of this function will be when you have an app that is just run as a one-off thing. So you want to collect all the messages and then terminate the app. So that will be the second flavor of this function. If you happen to be building a service from scratch and you choose to use Relaynet, there are 2 things that I think you need to keep in mind. One is that obviously you have to make sure that the UI and the UX will work when the user is not online. So don't assume that the user is going to be connected to the internet when they perform any action. And the other thing, and this is more technical, is try to embrace asynchronous messaging. Don't try to shoehorn RPCs to really get the best, get the most make the most out of Relaynet. You can mimic RPCs, as I mentioned earlier, but you really should try to avoid that and do it sparingly, only if it's really necessary. Now, if you are not building an app from scratch, but you already have an internet-based service, then one thing that you may want to keep in mind is obviously when you are integrating Relaynet is that you can do it gradually. So for each interface that you want to port to Relaynet, you really will only have to do two things. One is to obviously make sure that the UI and the UX will work when the internet is unavailable. And two, you will have to replace all of those RPCs with calls to the endpoint SDK. So one of those functions that I showed you earlier. So that means that you will have to replace HTTP requests with calls to this SDK. If you happen to be interested in adding Relaynet support to a pre-existing centralized third-party service, that's also possible. As you can see on the right-hand side, the proof of concept for Relaynet did this with Twitter. So the user was able to post that tweet with no access to the internet. So obviously a prerequisite for this is that the service provider must offer an API to do that. If that's not the case, then really there's no way to do that. So if that's the case, you will have to build two apps at least. So you will have to build the server-side app that will act as the interface between the end user's apps and that API for the third party. And obviously you will have to build a new client for that service, that third-party service, which instead of using the services API will be using your server-side app, or more specifically will be communicating with the Relaynet endpoint of that server-side app that you will have built. And that's it. Thank you so much for watching this, and if you've got any questions or you want to learn more, please visit relaynet.network/service-providers. Thank you.